Welcome back, students. Now we are going to talk about a equation of a plane in R3. Okay. So what is a plane? A plane is the set of all terminal points of vectors starting from a given point P naught and perpendicular to a fixed vector n. The vector n is called the normal vector. Okay. Thus, a plane is completely determined by a point P naught on it and a vector perpendicular to it. So, let us look at this picture. Let us fix this point P naught on the floor and take a perpendicular along the height. Okay. So, the question is, if you have a point and a perpendicular, what are all the points which are perpendicular to it, right? What are all the tail points of vectors which are perpendicular to it? So in this picture, we have drawn one particular vector which is perpendicular to n, right? Now imagine that I am taking all the end points, all the tail points of vectors which are perpendicular to n and passing through and starting from P naught. So you can see that it will give you the entire floor. So you can imagine wherever you are sitting, you imagine wherever you are sitting is the point P naught and you take a vector along the height of the room. Now you see what are the vectors that are perpendicular to this height. They will be all the vectors that are there on the floor, right? Starting from P naught. So that means any point on the floor will be a point on the plane. So what is the plane that you will get? It will actually be your floor. Right? That is how you should understand this. So now let us go back to the previous part. A line is determined by a point on it and a direction which is parallel to it. Whereas a plane is given by a point on it and a vector which is perpendicular to it. Okay. In the first case, you get a line. In the second case, you get a plane which has infinitely many lines on it. Okay. So now let us look at the equation of a plane. So equation of a plane passing through the point P naught and perpendicular to this vector n. So let P, x, y, z be any point on the plane. So this is the point that is given to you. What is this vector P naught P? It's given by x minus x naught, y minus y naught, z minus z naught, right? Now this vector lies on the plane, right? So therefore it has to be perpendicular to n. So since the plane is perpendicular to the vector n, the vectors P naught P and n are perpendicular to each other. And hence their dot product have to be 0, right? So what is their dot product? It's a times x minus x naught plus b times y minus y naught plus c times z minus z naught. Now since P is a general point on the plane, the equation is given by this is equal to 0, right? So you are taking all the points P such that this dot product is 0. But then you open the brackets, take the constant term on the right, you get a, not on the right, you club them. So you get ax plus by plus cz minus ax naught minus bx naught, by naught minus cz naught is 0. So you can write it in this way where d is equal to minus of ax naught plus by naught plus cz naught. So this is the equation of a plane. Now a quick remark. Suppose you have two equations of the same plane. The question is, what is the relationship between them? Relationship between them is that there exists a non-zero scalar alpha such that the coordinates, the coefficients a, b, c, d are scalar multiples of the coefficients in the other equation a prime, b prime, c prime, d prime. So this is what you get. So we will discuss this more in the tutorial, but this can be proved using the above discussion. Okay, because you can see that if a direction n is perpendicular, then any scalar multiple of n will be perpendicular, right? Okay, and in fact given a plane, there is only one vector which is perpendicular to it and all its scalar multiples, right? So let's say if n1 and n2 are both perpendicular to a plane, then they should be scalar multiples of each other. And that is what is being used in the last part. So for the remark, you can wait till the tutorial or try to prove it on your own. Okay, now we are left with two more things. First is angle between two planes. So there are two possibilities. One is that the planes are parallel, and we say that two planes are parallel if their normal vectors are parallel. Okay, so you can imagine that if the normal vectors are parallel to each other, then the planes that they will describe will also be parallel to each other. Alternately, if two planes are not parallel, that means their normal vectors are not parallel, then they intersect in a line. Okay. So if you are given two planes, so this is one plane and the base is another plane, they intersect and they meet in a line. Okay. So the question is, what is the angle between these two planes, and it's given by the angle between their normal vectors. So given two non-parallel planes P1 and P2, they are with normal vectors N1 and N2 respectively. The angle between the planes is defined as the acute angle theta between their normal vectors. So we don't look at the other angle. Okay, we look at the angle that's made by these two. Right? So there is an acute angle that is made by these two normal vectors, and that's the angle between the planes. And we know by definition that angle between two vectors n1 and n2 is given by this formula. Okay. So now let us look at distance of a point from a plane. So what have we done so far? We looked at equation of plane, then angle between planes. Now we are looking at distance of a point from a plane. So suppose this is the plane that is given to you, and this point E is the point outside the plane. You want to look at the distance from this point to the plane. What is that? You drop a perpendicular from this point to the plane. In this case, it is EQ, right? EQ is the distance of the point from the plane, because when you drop a perpendicular, you land at drop a perpendicular from E to the plane, you land at Q. So this height is the distance of this point from the plane. So this is what we have to compute. So let P be a plane with equation AX plus BY plus CZ equal to D. Then what is the normal vector? Normal vector is the coefficients of XYZ, which is A, B, C, right? Now let this point be x1, y1, z1. We wish to calculate this distance EQ, right, between E and the plane P. Now let R be a point in the plane. So take R to be any point in the plane. Then because R is on the plane, it has to satisfy equation of the plane. So if you put x, y, z equal to x naught, y naught, z naught, then this is what you get. Ax naught plus by naught plus cz naught equal to minus t, right? Because this is a point on the plane. Now we have a right angle triangle here, right? This is the right angle triangle because this is the perpendicular, right? We have to compute this length. Now we know the concept of projection of a vector onto another, right? So what is equidistance? It's nothing but the length of orthogonal projection of the vector minus v. So I am taking minus v because v I have drawn is in this direction. So minus v will be in the opposite direction onto minus n, right? Minus n will be in the opposite direction. So minus v and minus n meet at this point, and this angle, which is REQ, is the angle between them, right? So what is the orthogonal projection of vector minus v onto minus n? What is minus v? Minus v is the vector ER, right? Minus v is the vector ER, the negative of v. But ER is given by x naught minus x1, y naught minus y1, z naught minus z1. So by the formula of orthogonal projection, this is equal to the dot product of minus v and minus n, which is ER dot minus n, divided by norm of n, right? This is the orthogonal projection of minus v onto minus n. But what is ER dot minus n? It is given by this. ER is this and n is this. So you can compute this quantity. What is norm of n? Norm of n is square root of a square plus b square plus c square. If you open the bracket on the top, you get ax naught minus ax1 plus by naught minus by1 plus cz naught minus cz1. So ax naught plus by naught plus cz naught is equal to minus t. So you substitute it there. So you are left with minus of d plus ax1 plus by1 plus cz1, but there is a modulus. So negative sign you can ignore. So this is the answer. So what is the distance of point E from the plane whose equation is given by this? It's nothing but this quantity. So it's very easy to remember. Let me explain how. You look at the equation, you substitute the point E. That's your numerator. ax1 plus by1 plus cz1 plus d in modulus, because you are looking at distance, so it has to be positive. So you put a modulus here and you divide by the square root of the squares of the coefficients, right, which is the length of the normal vector. So this is the equation of the this is the distance of a point from the given plane. So let us stop here.